Good morning, students. In the last class of vector algebra, we learned that how to find the unit vector, direction cosines, direction ratios, and collinear. See, once we recall it, unit vector a cap, we will denote it as cap, not vector, cap. A cap equal to a vector by modulus a vector. Again, direction cosines, that's for r vector equal to xi cap plus yj cap plus zk cap. The direction ratio we can find it out, that is direction ratio is nothing but the coefficient of I, j and k, that is x comma y and z. Again, then direction cosines, it is x by r comma y by r comma z by r, where r equal to modulus r vector, that is only the value of r. We need only the magnitude, not the direction. So modulus r vector, we need to find it out, that is square root of x square plus y square plus z square. And using this video, we learned some result, that is square of the cosine is 1, sum of the squares of the cosines is 1, that is cos square alpha plus cos square beta plus cos square gamma equal to 1. And if it is for sine, the value will be equal to 2, that is sine square alpha plus sine square beta plus sine square gamma will be equal to 2. This we will be using to check whether the given angles form a vector or not. To check that, we have used in the previous class, we have used that this one to check whether the given angles form a vector or not. So, using all this, we have did the sums. Today the new thing we are going to learn is parallel, collinear, coplanar. See, for collinear or parallel, same condition, or parallel for a vector and b vector, the parallel condition is a vector is equal to some constant lambda into b vector. Collinear, the same thing, one vector equal to, for example, if the points a, b and c is given, a b vector is equal to some constant into bc vector, one will be common. If it is for a line a, b, c, if I am getting AB equal to BC, we cannot able to say that as parallel because B is common. So it must be in a straight line. That's why AB equal to lambda BC means we will be saying it as A, B and C lying on a line, that is collinear. For parallel, the same thing, but it will be in different, that is AB vector is equal to some lambda into CD vector. We may not get it BC or AC. If you are getting AB equal to BC or AB equal to AC, it will be collinear. If it is different vectors, we can say that is parallel. Then coplanar. Collinear means we know that 3 points lying on a same line. Coplanar, that is lying on a same plane. In this plane, lying on a same plane, we can say that as coplanar. So using this, we will do some problems. Last class we did till example 8.6. Say the problem. Example 8.7. Show that the points whose position vectors are 3 vectors are collinear. Here they have asked us to show that it is a collinear. See, position vectors, they have given it as position vectors. So we have to take the pointers OA vector, OB vector and OC vector. Let O be the origin. Let O be the origin and we will take the points as OA vector, OB vector and OC vector. So first one, OA vector equal to 2i cap plus 3j cap minus 5k cap. And OB vector equal to 3i cap plus j cap minus 2k cap. And OC vector equal to 6i cap minus 5j cap plus 7k cap. We will try to do it. We can find it out first. AB vector. We know AB vector to find it out. The second one, that is OB vector minus OA vector. Substitute that OB vector is 3i cap plus j cap minus 2k cap minus of OA cap, that is 2i cap plus 3j cap and minus 5k cap. So that is 3i cap plus j cap minus 2k cap. Now we can multiply with the minus. So minus 2i cap, minus into plus minus 3j cap, minus into minus, that is plus 5 into k cap. So we may get it 3i cap minus 2i cap is I cap. J cap minus 3j cap, that is minus 2j cap, minus 2k cap plus 5k cap, that is plus 3k cap. Actually, if one number is positive and another number is negative, means we have to subtract it and put the greatest number symbol. Okay, AB vector, either we can find it out BC vector or even you can find it out AC vector. So AB BC vector, OZ vector minus OB vector. OZ vector, that is 6i cap minus 5j cap plus 7k cap, minus OB vector, that is 3i cap plus j cap and minus 2k cap. So we can simplify it, 6i cap minus 5j cap plus 7k cap. Now multiply the minus inside. So minus 3i cap minus j cap, minus into minus plus 2k cap. So 6i cap minus 3i cap is 3i cap, minus 5j and minus j, that is minus 6j cap, plus 9k cap. Now when we check all the numbers, 3 is common. So we can take it out 3. I cap minus 3 into 2 is 6. So 2j cap. Now 3 into 3 is 9. So plus 3 into k cap. Now when we check, that is I cap minus 2j cap plus 3k cap is AB vector. So we have got it. BZ vector is equal to 3 into AB vector. So this shows that, see, B is common, one point is common. Therefore, we can say that A, B, C are collinear. So do you understand how to check whether the given points are collinear or not? Now we will do a problem related to parallel. Example 8.8. Say, find a point whose position vectors has magnitude 5 and parallel to the vector 4i cap minus 3j cap plus 10k cap. So we are supposed to find out a point with magnitude and parallel to a vector. So that parallel to a vector, we can take it as a vector. So let a vector is equal to 4i cap minus 3j cap and plus 10k cap. So parallel vector, the required vector. The answer will be required vector is equal to the magnitude into a cap. Since we have taken it as a vector, we have to write it as magnitude into a cap. So first we can find it out, a cap. A cap is nothing but the unit vector. Unit vector, we know the formula, a vector by modulus a vector. A vector, that is 4i cap minus 3j cap plus 10k cap divided by modulus a vector. We know to find it out, that is square root of x square plus y square plus z square. X square 4 square plus y square, that's minus 3 the whole square, plus k square is 10 square. So 4i cap minus 3j cap plus 10k cap divided by root of 4 square 16 plus minus 3 the whole square 9 plus 10 square is 100. So 4 I cap minus 3 j cap plus 10 k cap divided by, this is root 125. This is not a perfect square number, but we will check it whether any square number is available. You can divide it by 5. So 225. Again 5. Say inside the square root, if 2 times, if a number is there, we will be taking it out. It's in short form. Or see, actually this is root of 5 square into 5. So square and square root will be eliminated. So only 5 will be there inside the root. So 5 root 5. So this is a cap. Now you can write the required vector equal to magnitude. They gave us 5. 5 into a cap. 4 I cap minus 3 j cap plus 10 k cap divided by 5 into root 5. See, 5 and 5 we can cancel it. The remaining is 4 by root 5 into I cap minus 3 by root 5 into j cap plus 10 by root 5 into k cap. I know that 5 into 2 is 10. Anyway, so root 5 also can be divisible. So 4 by root 5 into I cap minus 3 by root 5 into j cap. 10 can be written as 2 into 5, and again the 5 is root 5 into root 5 divided by root 5 into k cap. See, this is 4 by root 5 into I cap minus 3 by root 5 into j cap plus 2 root 5 into k cap. So the point is, we know that the point will be x comma y comma z. That is 4 by root 5 comma minus 3 by root 5 comma 2 root 5. So this is the way we have to find it out, a vector or a point using the vector given along with the magnitude. So the next one is to check whether the given vectors form a right-angled triangle or not. So the question, example 8.9. Prove that the points whose position vectors 2i cap plus 4j cap plus 3k cap, we can take that as, since it is position vector, we will take that as OA vector. So OA vector equal to 2i cap plus 4j cap plus 3k cap. Then the second one is 4i cap plus j cap plus 9k cap. So we will take that as OB vector. And the third one, OZ vector equal to 10i cap minus j cap plus 6k cap. So prove that the points for whose position vectors form a right-angled triangle. Right-angled triangle, we know to use the Pythagoras theorem. So for a triangle, if it is right-angled triangle, we know the square of the hypotenuse. If it is ABC, square of a hypotenuse is equal to sum of the squares of other two sides. For this triangle, if we find it out, that is AC square is equal to AB square plus BC square. So this is what we have to prove. As per the values, we may get it. What is AC? The distance between AC. AB is distance between AB and BC is distance between BC. So we will find it out first, AB vector. Then we know that to find out the magnitude, it is modulus AB vector. So AB vector equal to OB vector minus OA vector. OB vector 4i cap plus j cap plus 9k cap minus OA vector, that is 2i cap plus 4j cap plus 3k cap. So that is 4i cap plus j cap plus 9k cap minus 2i cap minus 4j cap and minus 3k cap. So 4i cap minus 2i cap is 2i cap, j cap minus 4j cap is minus 3j cap, and 9k cap minus 3k cap is 6k cap. We know to subtract and write it. Now modulus AB vector, you know that is square root of 2 square plus minus 3 the whole square plus 6 square. That is root of 4 plus 9 plus 36. That is root 49. Actually, we need everything square to prove that is right angle triangle. So, I am going to find it out. AB square. AB square is modulus AB vector the whole square. Root 49 the whole square. So, we will be getting the answer as 49. Now, we can find it out. BC vector. BC vector is OC vector minus OB vector. It's easy to keep it in mind. That is second one minus first. So, OC vector minus OB vector. OC vector 10 I cap minus j cap plus 6 k cap minus OB vector 4 I cap plus j cap plus 9 k cap. So, that is 10 I cap minus j cap plus 6 k cap minus 4 I cap minus j cap minus 9 k cap. Now, we can subtract and write it 10 I cap minus 4 k cap, 4 I cap, that is 6 I cap. J cap minus j cap minus 2 j cap. 6 k cap minus 9 k cap, that is minus 3 k cap. So, the next step is to find it out modulus BC vector. That is square root of 6 square plus minus 2 the whole square plus minus 3 the whole square. Root of 6 square 36 plus 4 plus 9. So, this also we are getting the same value root 49. Now, we can find it out. BC square. BC square is modulus BC vector the whole square. Root 49 the whole square, which is equal to, again we have got it 49. See, two sides are equal. We know that in a triangle if two sides are equal, that is isosceles triangle. But our question is to check whether it is a right angled triangle. So, we have to find it out anyway. AZ vector. AZ vector is OZ vector minus OA vector. OC vector 10 I cap minus j cap plus 6 k cap. So, 10 I cap minus j cap plus 6 k cap minus OA vector. OA vector value we know 2 I cap plus 4 j cap plus 3 k cap. 2 I cap plus 4 j cap plus 3 k cap. So, now we will simplify and find it out. 10 I cap minus j cap plus 6 k cap minus 2 into I cap minus 4 into j cap minus 3 into k cap. See, 10 I cap minus 2 I cap, that is 8 I cap. This is minus j cap minus 4 j cap. We know if two numbers are negative, we have to add the numbers and put the negative symbol. So, we will be getting minus 5 into j cap. 6 k cap minus 3 k cap is plus 3 k cap. Now, it is easy for us to find it out. The modulus AC vector, square root of 8 square plus minus 5 the whole square plus 3 square. So, root 64 plus 25 plus 9. This is 64 plus 25, 89 plus 9, 98. So, modulus AC square is equal to modulus AC vector the whole square. So, root 98 the whole square is equal to 98. See, the previous two numbers we have got it as 49, 49. We know that when we add these two values, we will get that 98. See, so BC square plus AB square is equal to 49 plus 49, that is 98, which is equal to AC square. So, we have got it one side square equal to sum of the squares of other two sides. So, it forms a right angled triangle. See, here B is common. So, angle B is equal to 90 degree. Therefore, triangle ABC is a right angled triangle. So, I hope all you have understood this one. The next thing is to find it out coplanar. Coplanar, as I said, lying on the same plane. Collinear is lying on the same line, but coplanar is lying on the same plane. Say that there is a formula to check whether the given points is coplanar. That is box product A vector, B vector, C vector is equal to 0. See, box product, this we will be learning in brief in grade 12th standard. A vector modulus, that is determinant of coefficient of I cap, J cap and K cap. Same way we will write B vectors and C vectors and we will check it whether we will be able to get the value as 0. See that example 8.10. Show that the vectors, 3 vectors is given in the question to check whether it is a coplanar. So we can take one as A vector, 5 I cap, because they did not mention here as position vectors. If they are mentioning as position vectors, we will take that as OA vector, OB vector and OC vector. But here it is mentioned only vectors, so we will take it as A vector, B vector and C vector. So A vector is 5 I cap plus 6 J cap plus 7 K cap. B vector is 4 I cap plus J cap plus 9 K cap, and C vector is, so B vector is equal to 7 I cap minus 8 J cap plus 9 K cap, and C vector is equal to 3 I cap plus 20 J cap plus 5 K cap. So coplanar determinant, we'll write the coefficients 5, 6, 7. 7 minus 8, 9. Here the coefficient 3, 20, 5. We will now simplify and check it. Actually this is box product A vector, B vector, C vector. See, 5 into minus 40 minus 20 into 9, that is 180. Second value when we write minus 6, we will leave that corresponding row and column. 7 into 5, 35, minus 3 into 9, 27. Last, plus 7 into, leaving the row and column, 7 into 20, 140. Minus 3 into minus 8 is minus 24. Since already we have a minus here, it will become plus 24. See, 5 into minus 220 minus 6 into, this is 9 plus 7 into, this is 164. See here, this is 0, 10 minus 1100 minus 6 into 9 is 54. See, 35 minus 27, we will be getting it 8. So 6 into 8, 48. Plus, this is 8 to balance 4, 1148. See, minus 1100 minus 48, that is minus 1148 plus 1148, we are getting equal to 0. This is a simple way. The same thing we have got in 12th standard vector algebra chapter. The same formula we will be using there. So now we can write the given vectors are coplanar. The given vectors are coplanar. See, so today we have learned how to check collinear, how to check the given vectors are forms a right angle triangle, how to check the given vectors are coplanar, and if a vector is given along with magnitude, how to find out the parallel vector. See, we have almost completed the examples of exercise 8.2. Already few homeworks were given. This exercise is left for you to do as the assignment. So if there is any doubt, you can ask us in the interactive session. So thank you students, go through it, And in the next session, the new topic we have to learn, that is product of vectors. Hope you all understood this. We can see in the next session. Thank you.